All right, good morning, folks, and welcome to Plexus International. My name is Chris Peterson. I'll be your moderator today for improving the value of visual inspection MSA, how to make sure you get it right and prove it to the rest of the world by Plexus International. Like I said, my name is Chris. I'll be there in the chat for you today. I've got Jeremy Hazel with me, master trainer extraordinaire, Plexus professional. And today, before we get started, and a few more people are joining us, I just want to go over house rules real quick. If you do need any support for the webinar, you're curious if we're going to send the slides after or how you'll get that copy of the webinar recording, I'll be available in the chat for you. If you have any questions during the content for Jeremy or for the team for afterwards, we can get back to you. Send that through the Q&A on the bottom portion of your screen. Otherwise, sit back and relax. We do have some available content on our YouTube channel related to MSA and visual inspection. But with that, Jeremy, I think we can get started and let's get after it.
All righty. So welcome to today's webinar. My name is Jeremy Hazel, and I'll be the one taking you through improving the value of visual inspection. And I wanted to title this specifically around visual inspection, but a lot of these topics can apply to measurement systems analysis in general. So today I wanted to focus in on probably the most problematic portion of measurement systems analysis, and that's visual inspection. But if you go up a level and you raise up a level to the more generic content, everything that I'm going to talk about is generally applicable to measurement systems across the board. So we're going to be talking a lot about visual, but it could also apply to calipers, it could apply to scales, it could apply to any sort of measurement system you have. And the subtitle of this, I put a lot of thought into how to make sure you get it right. Because as an IATF subscribing or AS subscribing manufacturing facility, you're obligated to do these types of tests. And so you have to do them. But the question is, how do I get it right so that the test represents accuracy in what I'm going to experience when it goes out onto the floor? And how do I prove that to somebody? And how do I communicate it to somebody that does not speak measurement jargon, right? Spoiler alert, your management does not speak bias, does not speak linearity. They don't even speak gauge R&R. All they want to know is it passable or not? And will I get in hot water or not? So what we're going to be doing today is we're going to be looking at where errors come from. We're going to be looking at some of the most common failures that we've seen after 20 plus years in the field. And when I say common, you're going to relate to a lot of these because these are universal from my 20 years in the field. And then we're going to give you probably my best tips in how to make it count. Because the thing that irks me more than anything else is when you have to do something solely to show that you comply when it doesn't provide value to your organization. So my goal in all of these seminars that I do, how does what we're required to do help us inside of our organizations? So let's take a look at a little bit of the agenda here. First of all, we're going to look at visual inspection, benefits, limitations, and then our favorite thing, the failed use cases, right? These are horror stories from the field. Then we're going to talk about why visual inspection fails in so many cases. Then we're going to look at two types of measurement systems analysis that I use on almost a daily basis when I consult with organizations. And then we show you how to communicate those results in a way that actually drives decision. Because if you know how to read the measurement system analysis, you know how to communicate it in a way that adds value, there is a tremendous amount of financial data and, dare I say, statistical data around prophesizing, say, your escape rate that comes from it, if you know how to read it. Then we're going to connect it into some of your other QMS processes. So you're going to get the whole thing, right? From how it fails, what I'd recommend for it, how you use it to drive the value, and lastly, how you work with sustainability. So this is going to be all jumbled up into one complete system by the end of the hour. And then we're going to have about 15 minutes, give or take, for open Q&A. So as Chris mentioned, he introduced me. For those of you that have been on webinars with me before, I do a lot of the webinars here for Plexus International. And a lot of what I do when I go on site is connect the academics and the math and the theory of quality into your business management system. So this discussion on MSA is one that I have really wanted to do for a long time because it is single-handedly one of the most convoluted, misunderstood tools in all of the core tools in the automotive scheme. I think the only other worse one is SPC. That's a webinar for another time. So let's go ahead and start with visual inspection. And I kind of want to divide it up into the good, the bad, and the ugly. But here's the part. When it comes to visual inspection, ugly is just a matter of error in the measurement because there really is no solid, perfect definition of it. So let's take a look here at visual inspection in general. Now, when it comes to visual inspection, when we have an organization, they end up utilizing visual inspection for one or more of the following reasons. Organizations engage in visual inspection because, quite frankly, it may be more cost efficient. The second one, there may not be another viable alternative. What you are looking at may be so convoluted and so complex that some sort of a more, let's say, mechanical option hasn't even been created yet. And if you are a smaller company, there may be a lack of awareness that there are other best practices out there in the field that would get you a better, say, inspection than you have today. Now, we see the use of visual inspection in both attribute-based systems as well as variable. Now, for those of you that don't talk the tech here, an attribute-based system is one in which the data is largely binary, right? Present or not, right or wrong, 0 or 1. And so when you look at an imperfection, let's say you're looking at a car door, right? And you see a ding. The presence of the ding is either there or not. There is no size of the ding. There is no gradient for better or worse for the ding. There is just present or not, defect or not. But we do see in organizations' control plans, sometimes you do have an organization in which you can gather variable data, but you choose to inspect it from a pass-fail standpoint. So an example from my background on that is heat shrink position. We used to make harnesses in which the heat shrink had a location. That's obviously variable, right? But we chose in mass production to hold it up to a gauge and visually check if it matched up to an area of blue, in that case, on the gauge. So we chose to say good or no good, even though we could, through other means, gather variable data. So organizations end up, due to cost, due to viable alternatives, or due to the fact they don't know there's something out there, to use visual inspection for both the attribute style data as well as variable. Now, the thing that we need to remember is that the MSA study, right? The visual inspection also contains error, right? A person's visual inspection is never 100% accurate, much like any other type of MSA study for a variable gauge. You are going to get some error. This could be variation in the human being's ability to see, so their vision. This could be a small variation in the amount of difference you expect them to see, say like in color. And so we have to be able to quantify how much error we have in that system. And the reason why most people fail is because the error in a visual type system, it's harder to qualify due to the unpredictable and notoriously, let's say, error-prone nature of the human being. But when we go into organizations, there are largely two areas of your organization in which these errors occur. And I want to talk about both. The first way we get, so let's say uncontrollable error or uncontrollable variation in visual inspection is the team conducting APQP or new program launch. This team makes errors in their judgment. Now, keep in mind where we're at. We're developing a new program. We're in the early phases of program management. We're trying to decide what the detection value should be, even though we may be costing the program, and we decide at that point to use visual. That is an error that is made so early that you're going to end up living with that decision for the rest of the program. Now, we're going to talk about that error here in a second, but let's say that they get that right. Even if the APQP team gets this right, once we go into mass production, there can be errors made at the operations level. So let's say that the team made the right call implementing visual inspection, but when we hit the mass production stage and when it's 3 shifts, variations on the floor in mass production are the second place of error. So what I'd like to do, I'd like to kind of explain to you some different types of error that we've seen in both of these areas so that we know where this error comes from. And you probably, if you've been in the industry any length of time, have 100% seen this in your own organization. So let's start with 1, failures or errors that occur in APQP. Now, during new product introduction, let's go ahead and start there. Now, I'm going to use the term NPI, all right? During new product introduction, what I'm going to call NPI, you can call it APQP, don't really care. Vague product specifications are drafted around characteristics that are not even measurable nor feasible by visual inspection. And a very common example that I have seen propagated 101 times in, say, rust requirements, right? We will see a requirement called out from a customer that says no more than 2% of the surface area covered in the weldable zone. So they've identified the weldable zone and they've given an actual variable type of measurement. And what this means up here, in this weldable zone, you may get multiple areas of rust. Now, the company that we're thinking of, the company that we worked with, on their control plan, they visually detected this. Now, think about this for a second, folks. Do you know anybody that can take a surface area, calculate the amount of surface area covered by the rust, and then magically sum all of this up and represent it as a percentage of the total surface area? Absolutely not. This is a very common way that we fail in visual inspection. We make a commitment to do an inspection in which the visual component is nowhere even feasible to get to something, in this case, a variable measurement. And so then they wonder why their visual inspection fails, because what ends up happening is you get return after return after return. When the product goes into mass production, people get more frustrated. But the answer is there is never going to be a way in which we can take all of these little dots, combine them into one solid surface area, and compare them to a percentage of the whole. It just doesn't work that way. And the reason why I bring this up, this is a failure that we see a lot in APQP. There are programs out there that will automatically detect the presence of rust by vision and will do the calculation to sum up these as a percentage of the area under consideration. But the visual will never get there. So the first place organizations typically fail when it comes to visual is in program management, new program introduction. They sign up to detection methods which do not match with the capabilities to hit the spec that they signed up for. Now, the other way we see this happen, even if APQP gets it right, Well, let's do a second one real quick on APQP. This was a good one from my history here. We used to turn down different tubes, and we had a requirement: no nicks, dings, or dents. So if you are looking at no nick, ding, or dent, if there is an imperfection here, is it the depth of the nick, the length of the nick, the lack of protrusion above the surface of the nick? This was agreed upon by the client and was in their control plan. Now, again, under the cycle time that they had, can anybody scan the entire 360-degree surface of this tube and then determine whether or not one of these is present? One of the tools that I would recommend for further study on this, and this is something that'll be a whole webinar in and of itself, is the idea of operational definition, folks. Operational definition is one of the best tools you could use to stop errors in APQP. We do have videos on that on our YouTube channel, and I would encourage you to go check those out. Now, let's go ahead and take a look post APQP here and see what we get. Let me clear out my illustrations here. All right, perfect. And next one. Now, when we look at mass production, we have to remember here that MSA is the measurement system and is not just the evaluation of the appraiser. So what we have here is a very common fishbone. And the output of this is we go through and we say we need the correct measurement. And typically when we think about visual inspection, we focus way too heavy here. So let's say that it is possible to gauge through visual inspection. We will then put our entire focus on the operator. But where it messes up in manufacturing is we need to do the analysis. We need to look at the interaction around that operator. As an example, when we go into manufacturing, let's say that it is viable that we can inspect by visual, so APQP gets it right. But we position the operator between the workpiece and the light. So let's say the light is behind the operator and that operator is making a judgment call on the workpiece. The lighting may be acceptable. The inspector might be capable. But if you've taken webinars with me before, you remember me saying the action is in the interaction? The interaction between the inspector, the lighting, and the workpiece is where it messes up. And I bring this up because if you have 3 shifts, there's going to be one shift where they position the light in the upper right. There's going to be another shift where they shift it around to the upper left. Then there's going to be one shift that's going to put it behind it because it's just too much on their eyes. And this is where we get it right from an APQP side and completely blow it when we hit the floor. The other example that I'll give you that we see all the time, the inspector, if they are looking at something and they are in the wrong position to the workpiece, you might actually have what is called parallax error. Now, parallax error is caused by the operator and their position to the workpiece. And to illustrate this, I bring up a traditional clock. When you look at a clock dead on, you get an accurate time. But if you shift over to the left, does it look a minute or two this way? Yep. If you shift over to the right, does it look a minute or two back? Yes. So again, the inspector is qualified. The workpiece is, let's say, stable, but the action is in the interaction. So errors occur in APQP, and they also occur on the floor. So a couple of real life examples of this. The characteristic we're talking about is possible to inspect manually through visual means, but now the ergonomics and the sheer volume of the task may make it impossible. The top 3 mistakes that we see for visual inspection: we overcompensate for poor training of the mass production style operators by placing a select few in the position to do the inspection. We gauge our visual inspection off from our all-stars. Even though maybe you have 3 shifts and your all-stars are only on 1 or 2 of those shifts. And worse yet, let's say that you have all-stars on all 3 shifts. We reward them by inspecting more and more parts. And this brings me to number 2. We fail to assess the repeatability of the method after a representative time frame. Folks, how many people that have worked in industry, and I mean, this is a very common thing, are you as sharp after the 1200th part for a visual as you were when you first started that shift and looked at your first part? No. But yet, when you calculate your MSA studies, are they knowing that they are participating in a study? Yeah. Do they know they've got to look at a certain number of parts, maybe 20, 30, 50? Sure. Is it representative of the fatigue 6.5 hours into the shift at 1200 parts down the line? No. So not only have you created now a study that is not representative of how it's going to work in the field, but now you've actually engaged in some form of self-delusion. And the last one that I talk about, failing to consider the interaction of the operator with the part. I brought up the idea of parallax error. This is really crucial because when we do gauge R&R studies, MSA studies on visual inspection, we hold a lot of those things stagnant because we want a good result. You need to practice like it's going to perform in the field. So if it's essential that the light be 15 feet from the table at a 30-degree angle with this particular bulb, we need to put in process controls that don't allow the operator to move the light and thus change their position and interaction. So coming back to APQP versus the floor, these are the top 3 ways we see it failing for the floor. And then some of the decisions we make in APQP regarding nicks, dings, and dents in that tube, or the percentage of rust measured visually. These are some of the things that we see in terms of why visual inspection frequently fails. And one of the things that's, again, on our YouTube channel is a video on that operational definition that is single-handedly one of the best tools we can use to prevent that. All right, let's go ahead and do a poll because I've been jawing for a while. What we're going to do here is we're going to do a poll. And for those of you that have been in webinars with me before, I use the poll so that I can frame the rest of the conversation that we're going to do. So I'm going to go ahead and launch this thing. And I stop when I hit 70%, right? So if you want the fun to stop, participate at 70%. For those of you out there, before I go into the MSA more detailed portion, I need to figure out your scope of influence because I have people that determine when the visual inspection is used. Some of you live with the decisions made in APQP. Some of you may be performing it. Then I'm interested to see how you feel about your MSA visual activity, right? Sometimes it's a necessity of launching a program, but sometimes we actually use the results. And lastly, do you frequently get third-party certification issues in your MSA? Because I got to tell you, in our 3-day classes, you'd be shocked how many people are attending because they got on the naughty list. Give you a second here. We got 20% reporting out. All right, 40% reporting out. Good deal. All right, 62% almost there, 70% around the corner, folks. Finish strong. And as a statistics guy, I stop at 70% because at that point, we largely have grand means and there's no, say, data that's going to come in that'll move the needle. All right, let's go ahead and end poll. And what I like to do, folks, is I like to share some stuff with you here so that you're not alone on the island. Let's go ahead and share the results of this. So the good news is the people that are attending this, I feel good that we got at least the right people that can make some decisions. You determine where the visual inspection is used and then implement the visual inspection in the manufacturing. A few of you might perform it, and a few of you might be looking to read across then for drafting best practices. So hopefully, if you draft best practices and you determine where it's used in your APQP meetings, you'll identify at least a couple of those pitfalls and say, you know what, when we go to the next APQP meeting, these are things I need to watch out for. Now, the second one, the good news is most of you consider the MSA, let's say, a necessary part of launching a program, and it's tedious and largely regarded as, how do I put this? Busy work activity. All right. Now, the other one here, about 50-50, MSA is one of those things that everybody struggles with, so that one does not necessarily surprise me. All right. Let's go ahead and take a look at the two large areas here that I use on a daily basis. Now, for those of you that are really tech savvy, this is not going to be a tech savvy discussion, right? We're not going to dig into the math. We're going to talk about the results. And when I talk about the results, I want you to get the intent, because the math is largely just the math. We've been good at math for a while. So one of the visual tools that we use all the time is what is called a CrossTabulation study. It is in that blue MSA Core Tools manual, so it is largely known, but most people do not use it correctly. Now, high level stuff here. We're at that 10,000 foot cloud view, right? When you look at an MSA study, what happens is we look at the repeatability of the appraisers to make the correct calls regarding acceptance or rejection. Now, we're not going to go into the details, but typically what you will do, you will gather some parts, and typically around 50. And some of those parts are clearly bad. Some of them are perfect, pristine parts. But some of them may need to be in the shaky zone of acceptable. In my world, most of them are in that shaky zone. So let me give you an example. Let's say that I have overall length of something and I want to look at it visually. I'll have some that are knowingly short, like grossly short, like you can see it from across the room short. I'll have some that are really long, right? Like you can tell. And then most of my parts will be in that slightly good or slightly bad range. And you'll have to make them. You may have to produce those parts. You do 3 operators, 3 trials. And what this is asking, this method, is how often do you agree with one another? Now, you don't have to worry about the tech, but what they do, they look at operator A compared to operator B and the number of times they agree. And then what they look to is what they should observe and what they should expect. And the part down here is really what I want to focus on. At the end of the day, this is the part nobody ever uses. The cross-tabulation study gives you an overall effectiveness of each appraiser in the study. And generally, there are general acceptance criteria. And I say general. Your CSRs will have a play. There's a lot of factors. Don't get hung up on the criteria. Just know that there is criteria. And the thing that is very, very valuable, the gold, if you will, in this method is right here. This will calculate your miss rate. This is the number of times that it was a non-conforming part for you, but the operators put it in the box. Represented as a percentage, obviously. And right here, this is the false alarm. This is when they rejected the part and they put it in the scrap bin. Even though by whatever standard you judge the 50 on, they were considered good. Now, most people will pay attention to this column if they even got this far. But I want to show you how to weaponize the miss rate, and I want you to read the false alarm rate, okay? Because these columns, we don't understand the far-reaching implication of these. When you look at miss rate, And these are just things I want you to think about because this is interconnectedness. What is the impact on miss rate to the detection value of the FMEA that you're counting on? If you have a miss rate of 12%, but you say, well, based on the type of detection and based on this and based on that, this is a detection value at 2. You're lying to yourself. A high miss rate tells you that you have very poor detection. You need to take that detection value and raise it up substantially. This is one of the reasons why in the new AIAG VDA method, if you don't have good gauge R&R, you don't get to play in those lower numbers. It's 7 and above. At a 12%, you better brace for impact. Now, the other thing, let's talk about this. With this miss rate, we can calculate. Now, it's a little bit of chicken and the egg thing. The capability, if you know a historical capability and you have some miss rate, you're going to know how many parts in that shaky zone will approach the inspection and how many we should expect to slip past. Because if your capability is poor and you know you're consuming most of your tolerance and you know your miss rate is atrocious, you're going to get a high number of suspect shaky parts that are entering your inspection, and your inspector is far more likely in those little areas to put it right into the box and away it goes. They'll wave at it right as it goes by. This helps calculate your PPM for things like warranty, for escapes, all of that, right? And this comes back to this right here. I use this information from my MSA to calculate accrual rates. How much money do we have to put in the coffers in order to plan for the things that are inevitably going to get out? Most of the time, your miss rate information from your gauge R&R, your MSA study for visual, will not make it back to the financial side. But right here, the miss rate is literally screaming at you. This is your risk, and this is how often they're going to get it wrong based on X parts. The other thing for false alarm, I look at this as potential scrap cost created by our decision to use visual inspection. So if my visual inspection around a characteristic is so poor that we err on the side of caution and my false alarm rate, let's say, is 8.8%, again, I can use this information. Maybe what we need to do is add in a requalification of those things going into the scrap bin to make sure that we really have a reject. Because guess what? 6%, 8%, 4%, they're not going to be no good in terms of how they were evaluated. So in areas where I have very high false alarm rate, I will put in a secondary qualification to the characteristic because I do not trust my visual inspection. Because my false alarm rate is literally telling me they're going to throw a good part in the bad. So when you look at this, this is how you begin to communicate it. You use these miss rates, these false alarm rates, and you look at the application to the FMEA, into the control plan costs, into the scrap costs, and into the PPM, because guess what? It's going in the box. Now, when it comes to effectiveness, this is where we start getting a whole lot of work here and a whole lot of leverage. Does the IATF require documented evidence of competence for all people doing work that affects the QMS? Yep. Is this effectiveness rating the application of training? Yes, this is the competence. This is the competence of the inspector. So if you do your MSA studies, your competency evaluation, signed, sealed, delivered, done, finished. Also, you don't even have to come up with something different because you have already documented it. All you've got to do is put that inspector's name down there and say, this is how we do the competency evaluation of whoever inspector A is. Done. This is how we get a tremendous amount of leverage. I don't have to worry about tracking competency if I do my MSA studies correctly. Now, the last thing that I want to cover here on this MSA This is a big one. This is one of those get out of jail free cards. The measurement system allows you to know when to requote. Now, I want to give you a real life thing on this. I used to do injection molding, and we had a part that came through, and they wanted us to visually inspect for flash around the parting line. Now, flash around the parting line, for those of you that may not know, is plastic that we then have to trim off, cut off, whatever it is. It's right here. And so we wanted no flash along the parting line. And we gave the inspector 15 seconds to do this inspection. So the operator would take this flash. We did the MSA. Some parts were perfect. We had trimmed them clean. Some parts were gross. You could see the wing hanging off it, right? And a lot of the pieces were in the gray. We gave them 15 seconds and we got back good effectiveness, right? Now, here's the trick. 3 months into the program, they wanted us to check for spray overflow of the plastic spattering in the filter area in the same 15 seconds. We reran our MSA studies and we found instead of a 2% miss rate, we were up to that 5% miss rate. We were borderlining on being ineffective because in the same cycle time, we had to inspect 2 different areas. 6 months into the program, they wanted us to check for flash in this bushing area in the same 15 seconds. When we reran our MSA studies, we had jumped up to 10% to do that inspection. It was time to requote. Your MSA data will give you objective evidence on when it is time to requote based on additional customer requirements for that inspection. And it gives you a quantifiable number of how to do that. This is huge. So if you want me to do this, yep, we need to either increase the cycle time from 15 seconds to whatever it is that gets us acceptable, or I need to bring in another inspector and we increase our labor. See how this works? There is so much value for your MSA if you're willing to read exactly what it's asking you to do when it comes to miss rate, false alarm, effectiveness, and it 100% helps you when it comes time to requote. Now, best practices, because now you know where the pain points are. You know what this method is largely telling you. The way that it works for best practices, this is over 20 years in the field here. When I start looking at visual inspection, you're going to need golden samples as part of PPAP. Choose the parts with the customer. Get agreement on what is good and what is bad, because you're going to need those visual standards for the IETF. You're going to need the golden samples, let's say, as part of PPAP. And these will be what you come back to if there's a disagreement. Secondly, run the studies with the lowest common denominator. When I say the lowest common denominator, I'm talking about training. The training that you would give, the temp that comes in as, say, 6 months into the program on third shift with 2 days of training, use them. Because if you use your rock stars that have 20 years and work first shift, you're actually practicing a form of self-delusion, because when the world starts, you will not perform the same as your test. So you need to be working with the lowest common denominator that you would give the temp that would be doing the inspection if you cut them loose on the line tomorrow. The third thing, perform the studies in the exact same environment. Noise, dust, chaos, and this is a big one for me, fatigue. When I do my MSA studies, I grab my operators that will be doing it, again, with the lowest common denominator toward the end of the shift after they are already exhausted, because that is going to give me my truest representation of what I'm getting. And this last part, this is the one that nobody thinks about. Run your study in the cycle time quoted for the project. If you give them 15 seconds, then 15 seconds it is. Folks, this is huge. We sign up to 15-second cycles, and then what we end up doing is we then give them 10 minutes to think about the meaning of life with each part. That's not the way it works. So keep the cadence the same way you're planning on mass production, the same environment, the same fatigue, the lowest common denominator for training, and the same cycle time. Because when the mass production starts, that will be the risk. Now, the other thing that I'm going to give you here, we're going to talk about something called signal detection. Signal detection is, again, another method that's in the book, and we're going to keep this very high level. This is used when you have variable data, but want to inspect visually. And the way this works, you take your pieces and you measure the characteristic variably. And then you go from one end of really bad to the other end of really bad. And then you've got some parts in the middle that are really good. You run your test with the operators. And again, it's based on agreement. If the operators can agree that bad is bad visually, this is okay. They also agree where the parts are good. And what you're really trying to do is you're trying to figure out what I call the gray zones. The gray zones are like ambiguous zones in which they cannot agree with each other. And the bigger your gray zone, the weirder and the poorer your measurement system performs. So if you have the, let's say, luxury of being able to measure it variably, but you want to measure it in mass production visually, run your CrossTabulation and then check out your signal detection and what you're looking at for the gray zones. You know how bad the part has to be before your team can identify it. Now, here's the way this works. If it is tool aware, if tool aware is far more likely than a discrete break. Let's say that you're running a characteristic and you have a tool break, right? That will form a grossly negligent type of feature, right? I mean, it may be the hole isn't even present. But what happens if the tool wear goes smaller and smaller and smaller, and you're looking at that tool diameter from a visual perspective? This will tell you exactly where the diameter shrinks to where people can't identify whether it's passable or not. And coming back to the capability, if the variable data shows great capability, like here's your spec, and you know that the variable data is so awesome that you are so far from your spec limits, then you may be able to reduce the inspection frequency because they're going to be able to tell way in advance if something begins to shift from the left to the right. So the gray zones in signal detection are 100% the show. Now, here's the weird part. If you run your study and you say, hey, if 50% of the overall range is gray, which means we can't detect whether it's passable or not, what this is telling you, your operators cannot agree, and there is error coming back again to somewhere in that system. And it's always interaction, operator to lighting, operator to environment, operator to workpiece. So some of the best practices, again, under the signal detection, same thing as it was before. Make sure you allow for interaction with the operator part in signal detection, okay? Operator part makes a huge difference. Run the study with the lowest common denominator of training. Be realistic with yourself. Perform the studies in the environment. Make sure you allow for natural human variation to show itself. As an example, color blindness. It is possible if you are looking at two different colors, and I brought this up with wiring harnesses. We had a customer once where there was a brown wire and a pink wire, and you had to put them brown in this terminal, pink in this one. We were doing a visual inspection, and if you put the brown wire where the pink wire was, when you honked the horn, the airbag went off. That was a bad day. You know how we found out? Customer complaint. Guess what happened? Yeah. So again, run the study in the cycle time quoted and just be very realistic with yourself around this. And I'm really excited about what you guys had for who's in the room. because not only are some of you performing these studies, but some of you are actually making the determination on what studies are brought in. So definitely think about these. And when you set up your study, make sure that you're as realistic as you can get. Now, what I'd like to do here real quick, I'd like to just start with the second poll. Let's go ahead and bring this up. I'll go ahead and come back. Let's go into 3 to 7. Now you know kind of the story, right? In your opinion, how aware is your management on the benefit of impact of MSA in your operation? Now that you've seen the show, how can your organization benefit from linking MSA inspection into your larger system? The third one, and this is now the actionable one. What can you do tomorrow? Because education is good, but without action, it doesn't go very far. What can you do tomorrow to improve your linkage into MSA? And lastly, as we're looking at the interconnectedness between these systems, how are we doing this? What other training do you think your organization may need in order to do this? So I'll give you a second here. And then we'll wrap it up with some best practices and some integration. I'm interested in these so that we can see how closely you align to what I put on the next slide. Then we'll do some open Q&A. All right, 20% reported. All right, 40% reporting. Yes, that number is rising. All right, 55%, almost there, folks. And we are in good shape. All right, let's go ahead and kill it here. All right, just share this out with you folks. How aware is your management of the benefit of impact of MSA in your operation? There is a smaller minority, say what I would expect, that management doesn't adequately understand. So I think that a majority of people that I work with in that MSA field, they never dig past the results in order to understand the bigger picture. Secondly, how can your organization benefit from linking in MSA? New development and operational planning. 100%, folks. So the new development, again, APQP, different than operations. When it comes to operational planning, especially the use of temporary labor or inter-shift personnel switches, definitely plan for that risk. And then what can you do tomorrow to improve your linkage to MSA? Focusing on appraiser interactions, achieve better awareness from management. The ability to communicate up the chain is going to be vital. All right, let's go ahead and wrap this up and do some Q&A. Now, when we talk about the linkage into QMS, at this point, during quoting, standard costs can be developed based on methods. Folks, develop your standard costs. Roll throughput yields. The effectiveness of each station in isolation can be assessed and compared to customer targets based on volume. This comes back to the CrossTabulation study. If I have a 12% false alarm rate, and I'm barely holding on right now to the capability in terms of the parts produced every shift that the customer wants, I should say capacity. So if you have a 12% false alarm rate and you are at the edge of capacity, what is going to happen to your delivery rate? It's going to tank. So your MSA is going to tell you what stations are taking good parts and scrapping them out. Your detection values can be made more robust. Product audits can be more strategically planned for areas of high variation. And based on risk, areas of redundancy. If you know your miss rate is atrocious, you're going to have to put in redundancy. Or if you know that your false alarm rate is extremely high, you're going to have to put in redundancy to validate the parts that went into the scrap bin. Unless, of course, you're okay, just wasting money. And when we look at the DFMEA severity can be looked at in terms of the MSA, because the chance of us missing it, if it happens, could be so detrimental to the design side that we may decide visual inspection is not even on the table, and we need to go with something more variable and more automated. So the MSA studies, as we're looking at them here, can be linked in. And I hope that over these kind of 45 minutes we spent together, at least, you've got some idea of exactly how this works. All right, Chris, like come on and do some Q&A there.
All right, Jeremy, thanks. I'll let you grab a sip of water before we get rolling here. Thanks, folks, for spending your time with us today. As we do wrap up with this webinar, please do submit any questions you have to the Q&A portion. If we don't happen, I know there's a few rolling in. If we don't get to it, we will provide a written response via email to you, or we can reach out. And just a reminder as well, there's a survey that will pop up in your browser following a live event. Now, before we get started, I do invite you to check out our YouTube channel, Plexus INTL, for more information about MSA, other core tools, and more. So with that, Jeremy, let me kick off the first one here. It kind of summarizes a few. Now, if we're looking for more information between MSA or visual inspection in my plant, right? What would you recommend for further learning or for maybe a team approach?
Okay, for a team approach, 100%, the thing that I see a lot of organizations make the error on, Chris, is they go too far down the rabbit hole of the tech. So as an example, at Plexus, we offer a couple different things. We do the half-day MSA, half-day SPC, or the one-day MSA. Then we have the 3-day MSA and SPC for practitioners. But that one is a beast. That one is the one where we hand crank standard deviations, right? We all haven't had to do that since the 60s. So at this point, I'd advise going to a higher level in which you take a training like that half day in which we interpret the results. The interpretation of results these days, Chris, is the thing, because now everybody's got a software package. They're widely available, and you could even set up an Excel sheet to give you these results. But when I see people do this at your facility, it's always in the interpretation. The math is the math, and the math will never change. Go to a higher level training in which they focus on the interpretation of the results and how to take action from that standpoint. So that would be my best piece of advice. Do not worry about the tech.
Sure. Thank you. Now, here's one. And this goes back a few slides, but why, David's curious, why use visual inspection at all if the false alarm rate would be so high?
Sometimes there is a real financial implication. I'll give you an example. One of the smartest guys I ever worked with in the supplier side. He was traveling the country back in the 70s where he had the old Randy McNally maps and he was in the Midwest somewhere. He told me something when I started in supplier quality. He said, I want all the quality that I can afford. And what he was saying was many companies will source the lower cost vendors. And when you go to those lower cost vendors, they wouldn't have gotten the job had they overcapitalized for the higher end equipment. So one of the biggest things we see in automotive is the lower cost vendors being chosen, which comes with a higher reliance on visual inspection, because the cost of an operator, let's say over a 5-year program, is much less than a $250,000 visual station, that's automated. So that, unfortunately, I'm not even going to sugarcoat it. That's the reality. The other option is it could very well be that the visual inspection is quicker, whereas the more, let's say, accurate inspection might not meet your cycle time requirements. We do see that a lot. So those are the top two reasons why. It's just the reality in which we exist.
Okay, here's another one. We use a lot of visual inspection for a lot of parts and for a lot of defect items. How many parts and how many of the defects should we do MSA studies?
That is an individualized question. So this is an interesting one. Let's say that you have a final inspector and they're checking to determine whether or not there's no nicks, dings, or dents. Plus, also, they might be checking for flash. Let's say it's a plastic part around an area. And so there may be 3 or 4 categories that you are asking that inspector to check. One for flash, one for nicks, dings, and dents, and there may even be a legibility. Let's say that there's a molded in serial number. You might be checking for those. Those are all visual, but one person is doing it in one station. What I typically do there then is I will put all 3 of those characteristics on the part, and then I will mess up some of the molded in serialization. Some of it I will clean the flash. And so what I try to do, I may not isolate that individual characteristic, but if they're looking for 3 characteristics, I will have some that are perfect parts, some that have flaws that are egregious and just you can see from across the room. And a lot of them will be a combination of all of the different realistic variation they will see as inspectors. Now, your customer may want you to do one on the legibility of the mold, one on flash, one on nicks, dings, and dents. That's definitely a CSR discussion. But in my world, if the inspector is checking for 4 or 5 characteristics, I will put all 4 or 5 characteristics in because that tells me aggregately what they're experiencing. That's just my process, but it's definitely a CSR.
Okay, here's the next one. Now, we're aware it's risky to put special characteristics under visual inspection. What would the typical miss rate for target of special characteristics be?
It depends on the characteristic, and I'm not even gonna venture to say a typical. But let's say if a standard characteristic was 6%, let's say, or 5% according to generally accepted guidelines, your special characteristic, I would say it'd probably better be at least 10% of that. I mean, like 0.5%, you better be right on. Because if it's really special, yeah, as you're right, the visual inspection shouldn't even be going on.
Okay.
That's my opinion. So I realize that sometimes there are technology and budgetary constraints, but it needs to be probably 10%, in my opinion, of what a normal miss rate could be.
Here's another one. Do we need to do visual or MSA for each type of visual defect? For example, some are maybe due to raw material, some may be produced in-house during production.
I'm going to give you the black and white binary version, right? 0 or 1. If it is in the evaluation column on the control plan, you need a corresponding MSA with it. So if it is, let's say it's raw materials in your molder. If you are looking for the color of the raw material, let's say, there needs to be a visual on whether or not you can tell color from color. I'll give you an example. Let's say that this is red color, right? And brown. Very easy to tell the difference, right? But now, let's say that you get orange material, subtly different shades of orange. Can your operator tell the difference? Some things don't require an MSA because the difference between these 2 markers is very apparent. But when you talk about 2 different colors who are just a slightly different shade of the same hue, now we get into some gray zone. So what I would do anywhere in your control plan, you should have an MSA that proves that they can tell the difference in whatever the characteristic is. Because, and I'll just tell you straight up, a lot of your CBs are getting a little squirrely. If you can't tell the difference, that's probable shipment of non-conforming product, like nicks, dings, or dents. If you're the last person to put that part in the box and you can't tell the difference between a nick, a ding, and a dent, that's probable shipment of non-conforming product. We have had clients that have had major nonconformities as a result. So that's the gold standard version, let's say.
Sure. Now, I'm going to take time for 2 more, folks. If we didn't get to your question, we will send you a response afterwards, or feel free to send us a note too on plexusintl.com. Everyone registered for this event will receive a copy of the on-demand webinar, and you can even catch us on YouTube in the coming weeks. Now, to second to last question, I like this from Michael. How do you convince your customer to pay? the additional cost for the additional inspections. In Michael's experience, the customer demands these extra inspections because bad parts have escaped, but it's our problem, not the customer's.
Correct. This is why it's the same thing. What I'll tell you about whether I teach quality systems, whether I teach core tools or MSA, it is always a contractual negotiation, Michael. So it's very much it's the same challenge you're going to have. That challenge in business between supplier and customer has always been there, will always be there. It's in automotive, it's in aerospace, it's in commodities like bread and milk, right? So how you get the customer to pay is very much a contractual thing, and it comes down to relationship management. In my opinion, when I do new project quoting and we take on a PPM target, if I have some historical data around capabilities for similar processes and those sorts of visuals, I will give them the next step, let's say the future look of, this is probably how many parts from us are going to escape if we do not get capitalized for a better, more robust solution. Now they hate that answer, right? And then I say, now I need this, this, or this. And then it's a contractual negotiation. When you work with customers, and we talk a lot about delighting customers, customer satisfaction. The best way you can satisfy a customer is by giving them exactly what they expected to get from the time you initiated the program. So if I can tell you, hey, based on this, you're probably going to have further escapes from X. What I don't want is to promise them perfection when I bring on the program. And then 8 months later, we're the worst supplier in the world, right? And our PPM is spiked. So it's very much a back and forth. And my job when I used to work in program management, never oversell, right? Say that we're going to be perfect, and make sure that I can meet the target that I've committed to with them. Because if you can be reliable and consistent, that's a basis for improvement from there. But until you're reliable or consistent, you can't improve anything.
I like it. We'll do this last one, 30 seconds or less. Jeremy, what is an acceptable miss rate when the customer expects 0 PPM or very close to it?
This is, again, a customer negotiation. Everybody wants 0. Everybody wants 0. 0 is a lie that we tell children to make them think the world is safe. There is no such thing as 0, especially in visual inspection. So I know you want 0, but at visual, this is my perception, and this is what I'm going to give you over the next 6 months. Now, you may not like it, but again, now we can have an adult conversation around what we can do to minimize it, right? Communicate first, communicate often, and always, 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 when I use to run programs, bad news first, always, right? So bad news is we're gonna have 6% miss rate. Good news is now we can have a conversation about what we can do to improve inspection, knowing that we have this reality. Never, ever wait to surprise. Nobody likes surprises.
I like it. Well, folks, I'll start with the bad news. This webinar has ended for us today. Jeremy, thank you very much for your time. But the good news is we'll see you at the next one. Check us out on plexusintl.com. We have lots more upcoming events. Or if you have further questions about MSA, the other AIAG core tools, and more, reach out to us and we'll be in touch. Thanks, everybody. Thanks, Jeremy. Take care. Bye-bye.